Okay, this is the math section for May 14th. So we're continuing with square roots and talking about rational and irrational numbers. Just a reminder, when we are dealing with square roots, the only square roots that are rational are the ones that are along the diagonal of the multiplication table or perfect squares. And when we take the square root, we get a whole number. So for example, the square root of 9, which is 3, okay, so that's a whole number. It's a rational number. Square root of 25, which is 5, okay, those are rational. Irrational, all the rest. So anything like square root of 2, square root of 5, square root of 7, anything that's not along the diagonal of the multiplication table. So most of them are going to be irrational. And when we look at irrational square roots, a lot of times we don't have calculators. So we just need to be able to estimate, okay, using the ones that we do know. So trying to figure out what that number is. If we do have a calculator, but we don't have a square root button, then we can refine our answer even further by just taking a number, multiplying it by itself, and seeing how close we get to the number underneath of the square root. So again, this is all review. We've done this in class. We should be able to do that. So there's an example done for you. I'll do one more and then move on. So I'm going to do number 2. So square root of 14. Okay, so trying to think of the perfect squares that I know that are on either side. So I know that, think of this on a number line. All right, so a little bit bigger is the square root of 16, which is 4. Okay, and then less than that would be the square root, let's move it down a little bit, square root of 9, which is 3. So square root of 14 is in between those. So it's in between 3 and 4. And it's much closer to the 4 than the 3. I didn't draw that perfectly, but it would be something a little bit more over here. Okay, so what's a good first guess to figure this out? So I'm going to try, I think 3.5 is not large enough. It's definitely closer to 4. So I'm going to try 3.7. So then my check is I'm going to take 3.7 times 3.7, and I want that to be 14. So let's try that. 3.7 times 3.7. And I get 13 point, if we're going to round it to the 10th, 13.7. So 3.7 times 3.7 equals 13.7. Okay, so we're multiplying. Okay, now that's not quite 14, but it's really close. So I might as well try 3.8 times 3.8. Let's see where that brings us. 3.8 times 3.8. 14.44, so 14.4. So it's definitely in between. So what number is in between 3.7 and 3.8? So I'm going to try 3.75 times 3.75. And let's see what we get. 3.75 times 3.75. 14.06. That's going to be close enough. It's going to round to 14.06. I mean, technically that would round to 14.1. Okay, so it's a little bit too big. So we could go one step further, 3.74. Let's just see, since it's easy enough to type that in. 3.74 times 3.74, and that will definitely round to 14. I mean, that's, yeah, 13.99, which is pretty much 14, so 13.99. Okay, so I'm going to call this, so square root of 14, and I'm going to use approximate instead of equals because it's not exactly, so approximate is like a squiggly equal sign, and that would be 3.74. Okay, so this is how we could do it if we don't have a square root key on a calculator. And yeah, it takes more time, but it's not really a big deal. We're just multiplying numbers until we get to the number that's underneath of that square root symbol. Okay, so again, if you need to make a little number line, but think about what is on both sides of that number, and then that's going to give you the whole numbers to start with, so you can estimate with that, and then multiply the two numbers that you think it's going to be, multiply by itself, and then see how close you get, and then just adjust as you need to. Okay, and then here we're just labeling rational or irrational, a little bit more estimation. So let's start with the first one. So remember, rational means can be written as a fraction. Okay, and then irrational, they can't. So they're decimal numbers that just keep going on and on and on. All right, so first one in this box is 4 over 7. That's already a fraction, so for sure it's rational. Square root of 30, so think about the number underneath. Is it a perfect square? Is it along the diagonal of our square root table? No, so it's going to be a decimal that just keeps on going. Okay, so the next one, it is a fraction, but we can't have a fraction with that square root. So let's see if we can simplify that. What is the square root of 4? Is that going to give us a whole number? Square root of 4 is 2, so 21 over 2 is a fraction, no problem, so it is rational. Pi, all right, so that we all know that that number is non-repeating and unending, so that would be irrational. And then we have negative 27, so if we wanted to make that into a fraction, we just put a 1 under it, so that one is rational. Okay. Number 2, what is the closest approximation to a square root of 167? So again, it's just like we did on the previous page. So what is the closest number that we know the square root to, or that's going to be a perfect square? So look at the diagonal of the square root table, and we see that 13 times 13 is 169. So the square root of 169 is 13. And then 167 is really close to 169. So if we have 13 over here, it's going to be like 12.9 is the real, close to that, is going to be the real answer, but it says to approximate, so it's going to be 13. Okay, number 3, what's the approximate value of this? Now, what does this mean? We have a 2 in front. All right, so what does that mean? It just means multiply. So 2 times the number that's the square root there. So again, we need to approximate. So the square root of 47. What's a square root that we know that's really close to that? What about the square root of 49? Square root of 49 is what? 7? Okay, so that's about 7. So what's 2 times 7? So it's going to be about 14. Okay, it's not exact. It's going to be a little bit less, but it's about 14. Okay, number 4. Okay, so we need to estimate and then choose the numbers that's going to be between. So this is interesting. So the square root looks a lot different. We have some numbers that we're adding. So let's do that first. So it's just like order of operations when we have parentheses and we have a bunch of stuff inside the parentheses. We have to do, add that all up first. So let's do that. So square root, and then we just add those numbers together. So 16 plus 9, okay, that's 25, right? Plus 20 is 45. So it's going to be the square root of 45. Okay, so what is going to be the closest? So thinking about our number line, I know since we did that number 3, square root of 49, which is 7. Okay, so that's a little bit bigger. And then a little bit less is square root of 36, which is 6. Okay, so we know it's going to be between 6 and 7. So is there an answer that is between 6 and 7? Yeah, A. It doesn't matter. Those other ones are definitely not going to work because they're all larger than 7, and we know it's not larger than 7. So again, thinking about what we would do to estimate, is it going to be right in the middle? No, it's going to be closer to the 7. Okay, so that's it for that. And that's it for May 14th.